Hello everyone, and welcome to our last unit of this school year, which is pretty crazy. So we're going to be talking about trigonometry for this whole week, and some of it will be review from when you were in grade 10, and some of it might end up feeling a little bit new, but that's okay because you'll have a little bit of a base to start with. Even this first part that we're doing right here is even like a grade 9 review concept that we just have to be reminded about before we move forward. So you're going to have 4 new lessons this week to do and 1 last quiz for the whole school year. So you should really be proud of yourself for making it this far. So let's start with our first day, which is talking about the primary trig ratios, which if you remember on your calculator, you have these buttons at the top that say sine, cosine, and tangent. So we're really going back to those. Those are what we call the primary trig ratios. Those 3 things are ratios. We'll get to them in a minute. But first we're going to recall that the Pythagorean theorem states, you can add that in there, a squared plus b squared equals c squared. And you definitely remember that formula. It always has to do with right triangles. So in a right triangle, the square of the hypotenuse, which is c, is equal to the sum, when you add up, the square of the legs, a squared plus b squared. What side is our hypotenuse? It's always the letter c. It's always the longest side that is across from the right angle. So we're going to label it C. Which sides are our legs? A and B. You can put A and B. You can also switch it up and put A at the bottom and B on the side. It doesn't matter. The one that matters the most is that you label C. And then we see that A squared plus B squared equals C squared. You can also write that down there. All right, so for a right angle triangle, if 2 sides are given, you need to find the third side. You need to use Pythagorean theorem. So here we have 8, 6, and C. So it already even labeled the sides for us, but I'm going to go ahead and label here A and B, and C is across from the right angle, so that's perfect. So let's write out our formula, which is A squared plus B squared equals C squared, and you want to fill in what you know. So let's go here and say we have 8 squared plus 6 squared equals C squared. We don't know C, so we're just going to leave it as the letter C. When you put it in your calculator, you got 64 plus 36 equals, again, C squared. When you put 64 plus 36 together, you should get 100. And our last step is, well, we don't want C squared. We want the value of just C. So you need to do the opposite operation to get C by itself. The opposite of squaring, hopefully you remember, is square rooting. Looks like this, so that they can cancel out. So we square root on both sides to keep it balanced. And in the end, you should have C is equal to 10. So what I want you to do is try the next one on your own. I'll help you set it up for a second here. Just because it's a little bit different. It's close. It's similar, but it's a little bit different. Because notice how they have B here. It's a little bit hiding. But there's B, there's A, and we know across from the right angle is our C. So when you fill in the things that you know, we know we have 48 squared plus B squared is actually the thing we don't know, so we're going to leave it as just B. And 50 squared goes on the other side of the equal sign. So remember that your goal is trying to get this thing by itself. So I'm going to let you try it on your own, and then you can check the answers to see if you got it right for what the length of B is. So moving on from that little piece of review, because that's what it is, you've seen it before, we're going to move forward and say that trigonometry is triangle measurement. That's really what we're doing. We're trying to find the measurements of side lengths and angles in a triangle. So the primary trig ratios are sine, cos, and tan. And if you remember from last year, which hopefully you do, you have this special acronym called SOHCAHTOA that really helps us out. So what does that mean? Well, the SO comes from sine is opposite over hypotenuse. There's your SO. The CA comes from cos is adjacent over hypotenuse, like a fraction right there. And TOA comes from TOA. Tan is opposite over adjacent. But what are all these words? So let's, on this diagram off to the side here, do some labeling. So this theta symbol here, that's what it's called, theta, it's a Greek letter, It just is a letter that represents an angle. So we're going to put that symbol right here inside to represent an angle. So the easiest thing to label first is your hypotenuse, because the rules don't really change. There's your right angle, and across from it is always the hypotenuse. I'm going to label it as H for hypotenuse. Another easy one to label is going to be your opposite. So you're going to look at the angle that we're focusing on. There's our angle. What side length is opposite that angle? Well, it's going to be in that direction, which is opposite to it. So there's our O. And that word adjacent just means beside. So which side length is beside? Well, we know that the H is, but we already discovered that that's hypotenuse, so that one's done. The only other side length that's left over, that's also beside, is right here. So here's our adjacent side length. So when we are using these fractions, like sine theta is opposite over hypotenuse, that means that sine of this angle here is going to be the opposite side length divided by the hypotenuse side length. And same thing for cosine and same thing for tangent. And we're going to take a look at that in a second. So we'll try example A together, and then you're going to do B on your own. It says to set up all of the primary trig ratios for the following angles. So we're going to need to pick an angle, because there's no angle labeled here. So I'm going to go ahead and say that theta is going to be this angle here, because it's going to make a difference if you pick theta to be this angle up at the top here, but I'm going to choose this one. So step one you always want to do is label. So maybe I'll put that up there. Label your sides. So we're going to go with hypotenuse first because it's easier, across from the right angle. Hypotenuse across from our angle is opposite, and beside is adjacent. So we have it all labeled. So now let's put it together. Sine theta, remember it's SOHCAHTOA, which I think an important strategy is to always write that at the top of your pages. And whenever you're doing work or practice questions or the quiz that's on Friday, write it down on the top of your page so that you remember. SOHCAHTOA. So S is opposite over hypotenuse. So our opposite is 6 over our hypotenuse, which is 10. And we can even reduce that because we like to reduce, and say that it's 3 over 5. If you forget how to reduce, remember we can divide the top and bottom by the same thing. Divided by 2, divided by 2. Okay, now let's do cosine. So cos theta is equal to, well, let's take a look, A over H. It's from the Ka of SOHCAHTOA. Our A is 8, and our H is 10, and we can reduce that to 4 over 5. And lastly, we need to do tan theta, which is, again, we see here it's opposite over adjacent. So our O is 6, and our adjacent is 8. You can also reduce that to 3 over 4. So now you just found the primary trig ratios of that first triangle. So now I want you to do that again in part B. I want you to pick, I'll even tell you, you can pick, let's do the angle up here. Make that theta, label your opposite adjacent hypotenuse, and show me what your ratios are, and you can come back and check your answer. Now what's the point of all this? We did some labeling and we found some fractions, but what does that mean? We haven't really done a whole lot of math yet and solving things, so we're going to try here. In this question, consider this triangle here. We have an angle, we have one side length, and we're missing one. How do we find x? So step number 1 is always going to be to label. So we have the angle that we're using to kind of base off our calculations there. So we label our hypotenuse first, then our opposite, and adjacent. Step number 2 is going to be to determine what you have and what you need in terms of your side lengths. So we have an angle, what we're looking for in terms of like what side lengths do we have, what's given to us. It looks to me like the only side length that we know an actual number for is the number 4 centimeters, who knows, is the adjacent. So we have adjacent, and the one that we're looking for, that's like what's the missing side length, that's represented by x over here. is the opposite. So let's take a look at our SOHCAHTOA here. And we decided that we have A and need O. Well, which of these have O and A in them? That's O and H, nope. That's A and H, nope. This one is O and A, so we know that we have to use tan. So let's set it up. So to have a need, so that you can decide your ratio, because in the end, you're gonna have to pick either sine, cosine, or tan. So, step number 3 is to set it up. So we have tan of 45 equals 2, and it says here, opposite over adjacent. Our opposite is x, and our adjacent is 4, which is perfect. So now here comes the tricky part. So pay attention, be careful, it's going to take some practice. I think the easiest thing to do is take your left side here and put it as like a fraction over 1. And my note here is going to say we have to cross multiply. So you're going to take your fractions here and you're going to cross multiply. Literally that means go across and multiply things on the diagonal. So if I do 1 times x, that gives me just x. I do my equal sign and now I do the other diagonal. 4 times tan 45, we can just smush that all together and say 4 tan 45. And I want you to plug that into your calculator right now so you can see if you get the same answer as me. 4 tan 45, or you can even do 4 times tan 45, and your answer should be 4. And you can put centimeters if you want to. And if you didn't get 4, send me an email and we can figure out how, because that might be something up with your calculator. But that's the strategy that you want to use to solve it. You're going to set it up and cross multiply. That's important. Is it going to take some practice? Yes, but I know you've seen it before and you can do it. So your job now is going to be to determine the length of A, B, and C. Those 3 questions, solve for the missing side length, so Y, X, and Y below, and then go back and check your answers. Good luck. See you in the next video.